Good morning, class. Countdown to finals is underway. We're at 6.2. Arithmetic sequences in series. What is an arithmetic sequence? It's a sequence where the terms in the sequence are separated by a common difference. And we usually refer to the common difference as D. An example would be 1, 3, 5, 7, 9, and so on. Hopefully you guys could tell me that the common difference is that it would be 2. The difference between these terms is 2. It's going up by positive 2. To find the common difference, you take the current term and then you minus the previous term. So for example, 7 minus 5 is 2, and so on and so forth. So that is what an arithmetic sequence is, which lets us do more with sequences. If we recognize the pattern, we can do that. And then we're going to come up with some formulas today. Alright, so determine the common difference and find the next 3 terms in the sequence. So this goes 12, 9, 6. So again, to find the common difference, it's just pick a term. I'm going to say 9 minus the term before it, which is 12. So it's negative 3, which, do you have to do all that work? Probably not. A lot of you guys could tell me that that is going down by 3s. So to get the next term, you add another common difference. You keep adding common differences to get the next term. So if I add a negative 3 to 6, my next term would be 3. Then add another negative 3, I get 0, and then negative 3. These would be the next 3 terms in this sequence. Okay? Example 2 is 3, 7, 11, 15 arithmetic. Well, let's just double check. To go from 3 to 7, it's plus 4. So the common difference would be 4. 7, 11 is a plus 4. 11, 15 is plus 4. So yes, because it has a common difference of 4. Okay. Now we are going to skip examples 3 and 4. Those will be the notes for tomorrow. We do not need to know those for today. So that is arithmetic because it's a common difference of 4. So let's go down to our formula now. Now you guys should realize now that if I want to know some term of an arithmetic sequence, think about it this way. If I know I start at 1 and then I'm going up by 2s, to get to the 5th term, I had to add 2 how many times? Well, I had to add 2 4 times because I'm at 1 and I want to get to the 5th term. There's 4 differences that happen. So to get any term, you need to know what the first term is, and then you have your common difference, and you add how many common differences. It's 1 less than the term number you're on. So if I'm on term 5, I want to add 4 differences to the first term to get up to the term 5. And that is how this formula was generated. So please write this down, make sure it is correct on your screen. A sub n equals a sub 1 plus d times n minus 1. Alright, let's see what we can do with this formula. Find the 36th term. Okay, that's a lot. But in order to find the 36th term, we need to find a general formula. To find the general formula, we need 2 pieces of information. We need the first term, so that's good. And we need the common difference. D is equal to negative 2 minus negative 7. Or 3 minus negative 2. So that's positive 5, because it's going up by 5s. So now I can write the nth term. A sub n is equal to the first term, negative 7, plus the difference, which is 5, times n minus 1. That's my general formula. I can use this now to find any term I want. That's what's great about arithmetic, and we have this formula. So I want to find the 36th term, so I'm going to say, well, what is the 36th term? When n is 36, I get negative 7 plus 5 times 36 minus 1, or 35 differences. So if you type in 35 times 5, and then add a negative 7, you get that the 36th term in this sequence is 168. So if we would have written that out, we would have gotten to 168. Now, find the common difference given that the first term is 2 and the 5th term is 94. To do this, the easiest way to do this is think of it as slope, or an average, right? Because if it's a common difference, it's going up by the same amount. So that means that we jump 94 minus 2, or 92 of a value, for the sequence value, in a value of 5 minus 1, or 4 terms. So we get 92 divided by 4, because again, that's how much it went up by, and that's how many terms it went up by. So we have to average, like, well, how much did it go up by term? That'll give us our common difference. And so we get that our common difference is 23. And that's all we have to do for that. This leads us into, there's also a sum of the first arithmetic, sum of the first n terms of an arithmetic sequence. So if I want to add them up, I can figure out, so for example, 1 plus 2 plus 3 plus 4 plus 5 all the way to 100. I'm sure you guys have heard that question before. What's the sum of the first 100 terms? This will allow you to pretty easily calculate that. Okay? To do that, the sum of the first n terms is how many terms you have times averaging the first and the last term. Oh, that's not right. That should be an n. A sub n. I was thinking ahead. All over 2. And that makes sense, because if you think about it, let's take that 1 through 100 one again. 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. So adding those together, but the problem is we can't say then times 100, because we're using 2 numbers at a time. So really there are 50 pairs of numbers. So that's where the divided by 2 comes in. So let's do this. Find the sum of the first 50 terms of this sequence. Well, we know, I'm going to write out what we need to find. So the sum of the first 50 terms of this sequence is equal to 50 times 11 plus, what do I not have? I don't have the last term. So that means we need to find that. We'll get over that in a second. So I fill out what I know, that's all I know. Well, luckily, remember, we have a formula for a sub n. A sub n is that formula I gave you on the other page, so we're going to have to come up with that formula for this problem, unfortunately. But it's actually not that bad. Hopefully you guys see the common difference is plus 6, and the first term is 11. So remember, for the nth term formula for an arithmetic sequence, it's the first term plus the difference times n minus 1 terms. So we need the 50th term to complete this problem. So 50 minus 1 is 49 times 6 plus 11. So this tells me that the 50th term is 305. Now that I know where this ends, I can complete the sum. So I'm going to put the 305 right here. Now I can find the sum of the first 50 terms. It's 50 times 11 plus 305 divided by 2. So it's 50 times 158, which is 7,900. So if we took every single term and add them up from this term to the 50th term, it would add up to 7,900. Alright, and now, let's do it one more time. We have a problem though. I don't know what term this is. What is n? So if I do s sub n, I don't know what n is. I do know that the first term is 16 and the last term is 300 over 2, but I don't know what n is, so I'm stuck again. I need to find out what n is. So we're going to have to do the same thing. We need to come up with an a sub n formula to solve that. We know that a sub n is 16, that's the first term, plus, we know the common difference is plus 4, hopefully you guys see that, 4 times n minus 1. So here's where it's a little different. This time I don't tell you what n is because I don't know it, but I do know that I want to know what n is when this value is 300. So I'm going to write a 300 over here, and I want to know what n is. I'm going to distribute now. Okay? So I get 300 equals 4n plus 12. 300 minus 12 is 288 for 4n, which means n is equal to 72. So that is the 72nd term in that sequence. So now I can take this number and sub it in over here. So S sub 72 is 72 times, and then that was 316 divided by 2. I believe the other one was 316 also. Yeah, it was. So now we have 158 again. So 72 times 158, and we get 11,376 if we add up all those terms. So again, with sum, a lot of the times you're going to have to go back to the a sub n formula. You need to be able to use those two interchangeably. Okay? Tomorrow we'll do, the next video will be very quick. It'll just be those two problems, kind of more expanding your idea of what arithmetic is. I will see you guys later.